In this century, it is highly likely that humanity will detect signals from an extraterrestrial civilization, potentially unveiling profound knowledge about the universe beyond our solar system. NASA launched the Voyager 1 probe into space in 1977, unaware that this small spacecraft would go on to accomplish one of the most remarkable and groundbreaking feats in human space exploration. Over time, Voyager 1 has become an enduring symbol of curiosity and discovery, capturing the collective imagination of scientists and the general public alike. It has not only revolutionized our understanding of the outer solar system, but continues to provide valuable data that enhances our comprehension of the cosmos. Its relentless journey into deep space embodies the essence of human ambition, the insatiable desire to explore the unknown. Recently, however, NASA's Voyager 1 had a mysterious encounter with an unidentified object in space, leaving physicists baffled. What exactly did Voyager 1 detect? Could it be evidence of something beyond our current understanding? And how much longer will the spacecraft continue its incredible voyage? These questions have sparked intrigue among scientists and space enthusiasts alike. Voyager 1 began its historic journey on September 5, 1977, when a Titan III Centaur rocket carried it into space from Cape Canaveral, Florida. Its primary mission was to capture detailed images of planets and moons while studying the atmospheres, magnetic fields, and ring systems of Jupiter and Saturn, with a particular focus on Saturn's largest moon, Titan. However, its mission quickly expanded far beyond initial expectations. Despite being roughly the size of a small car, Voyager 1 was equipped with an array of cutting-edge scientific instruments, including cameras, spectrometers, and plasma detectors. These tools allowed the probe to gather crucial data about the celestial bodies it encountered. The probe spent approximately 2.5 years traveling toward Jupiter, where it made its first major discovery. On March 5, 1979, Voyager 1 conducted a close flyby of a gas giant, capturing breathtaking images and collecting extensive data until April of that year. Shortly thereafter, Voyager 2, its twin spacecraft, was launched on a similar trajectory. Together, these probes uncovered numerous groundbreaking findings about Jupiter and its moons. One of the most astonishing discoveries was the detection of active sulfur volcanoes on Io, Jupiter's innermost Galilean moon, an observation that had never been made from Earth or by the earlier Pioneer missions. The four largest Jovian moons, Io, Europa, Ganymede, and Callisto, were revealed to be part of an intricate and dynamic system, challenging previous assumptions about their nature. Additionally, Voyager 1 confirmed that Jupiter possessed exceptionally strong magnetic fields and powerful radiation belts, posing potential dangers to any future spacecraft venturing too close. After completing its mission around Jupiter, Voyager 1 set its sights on Saturn. On November 12, 1980, it made its closest approach to the ring planet, passing approximately 75,000 miles above its surface. During this encounter, Voyager 1 discovered that Saturn had far more moons than previously believed, and its extensive ring system was composed of countless small particles. Perhaps one of the most significant findings was that Saturn's largest moon, Titan, had a thick atmosphere, making it unique among moons in our solar system. This discovery piqued the interest of scientists, as Titan's atmosphere suggested the possibility of complex chemical interactions that could be relevant to the study of life's origins. After completing its primary mission, Voyager 1 embarked on a new chapter in its journey, eventually leaving the confines of our solar system in 2012. This historic milestone made it the first human-made object to enter interstellar space, the vast, unexplored region that lies between the stars. More than 13 billion miles from Earth, the spacecraft continues to transmit data, offering unprecedented insights into the nature of the cosmos. Initially, scientists expected that Voyager's transition into interstellar space would be a slow and uneventful process. However, they were surprised to find that this boundary was far more complex than anticipated. The Sun constantly emits a powerful stream of charged particles known as the solar wind, which travels at supersonic speeds of over 620,000 miles per hour. Some of these particles can reach speeds up to 10% of the speed of light. Accompanying this solar wind is the Sun's magnetic field, which extends outward and interacts with the interstellar medium. Beyond our solar system, the interstellar medium is composed of particles originating from distant supernova explosions, violent cosmic events that generate incredibly energetic ions known as galactic cosmic rays. Normally, the solar wind acts as a shield, preventing these cosmic rays from penetrating the inner solar system. However, as Voyager 1 moved farther from the Sun's influence, it began to experience a gradual shift in its surrounding environment. In 2003, Voyager 1 entered a region where the solar wind had slowed down to subsonic speeds, suggesting that it was approaching the boundary between the solar system and interstellar space. Then, in a sudden and unexpected turn of events, the probe detected an abrupt and dramatic drop in solar wind intensity, a decrease by a factor of 1,000. Within just a few days, the spacecraft's instruments indicated that the solar wind had become nearly undetectable. At the same time, Voyager 1 recorded a significant increase in the levels of galactic cosmic rays, which supported the idea that it had crossed beyond the Sun's protective bubble. However, one puzzling anomaly emerged. The cosmic rays were not arriving from all directions, as scientists had expected, but instead appeared to be coming from a specific direction. Adding to the mystery, Voyager 1's instruments failed to detect any significant changes in the surrounding magnetic field, even though the density of solar particles had dropped. This contradicts existing models, which suggest that the Sun's magnetic field should be at a noticeable angle compared to the galactic magnetic field. These unexpected findings have led researchers to re-evaluate their understanding of the complex boundary between the solar system and interstellar space. Another strange phenomenon observed by Voyager 1 was a faint, persistent plasma hum detected in the interstellar medium. Scientists likened this sound to a gentle rain, as opposed to the sudden bursts of energy usually associated with solar storms. Since 2012, the spacecraft has been continuously monitoring these plasma waves, revealing that interstellar space is not as silent as once believed. Despite its incredible resilience, Voyager 1 has begun to experience technical difficulties due to its advanced age. In recent years, one of the spacecraft's key systems, the Attitude Articulation and Control System, AACS, responsible for keeping the antenna pointed toward Earth, began to malfunction. Without any apparent interference, the probe started sending back inaccurate telemetry data, relaying information through a long-defunct onboard computer. As a result, the data became distorted, making it difficult for engineers to determine the probe's orientation. This unexpected issue raised concerns about whether it was finally time to retire the legendary spacecraft. However, NASA's engineers successfully devised a solution by instructing Voyager 1 to switch back to its original computer system, allowing communication to be restored. Despite these challenges, both Voyager 1 and its twin, Voyager 2, continue their historic missions. Each spacecraft carries a golden record, an interstellar message in the form of sounds and images representing human culture, designed to serve as a time capsule for any potential extraterrestrial civilizations that might one day discover them. These records are expected to last for billions of years, outliving Earth itself. Even as the Milky Way and Andromeda galaxies are destined to collide in the distant future, the Voyager probes may still be drifting through the vastness of space, carrying with them a small but profound testament to humanity's enduring quest for knowledge and exploration.